Assalamu alaikum wa rahmatullah. I welcome you all to the 12th video. Wow, this is amazing. This is the 12th video. We have a dozen videos already. Okay, this video is about work, energy, and power, and I'm not going to waste time. I know that you already have ideas about what work is, what energy is, and what power is in physics from your secondary school education. Okay, section 3.1 forms of energy. We know that energy exists in many different forms. We are familiar with that, but there is something that I need to talk about at least. The world energy resources are of two types. We have renewable and non-renewable energy resources. The renewable are those that can be replenished, that can be replaced after use. And here are a few examples. We have solar energy, wind energy, hydroelectricity. We cannot use all of the solar energy. When it falls on solar cells, electricity is produced, meaning we can use it to generate electricity. Light from the sun is also important in the production of carbohydrate in green plants. We all know the process of photosynthesis. Then we have wind energy, and this turns windmill, which produces electricity for work in the farm. Hydroelectricity in dams, water tanks, generators, and produces electricity, e.g. the Kainji Dam. Other examples are tide and oceans. Then we also have the non-renewable energy resources, those that are not replaced after use. We have the petroleum, okay. From the petroleum, we have the gas that is used in power stations to produce electricity, and on and on. We have coal, we have nuclear energy, meaning the energy coming from the nucleus of an atom. Okay, what again? Food eaten by man is broken down and energy is released for human activities. Okay, then the concept of work. The concept of work. They say that the term work can have several interpretations in ordinary conversation, including it can mean mental activity such as working in the office or reading in school. But in physics, it has only one meaning, and here is the meaning. I like it. They put the background in red for you to recognize it easily. They say work is said to be done whenever a force moves a body through a certain distance in the direction of force and is equal to, meaning if you want to calculate it, the work is the product of force and the distance moved in the direction of force. This means that if a force is applied on an object, it has to move, the force has to cause change in position of the body, okay, from one point to the other. It has to displace the body before work is done. If you apply a force on an object such as a car, you try to push it, you put a lot of force on it, but it doesn't move, you have not done any work on the car. The car has to move for you to do the work on the car. So they say, for example, work is done when you drag a lump of stone a certain distance. Can you see? Or when a body is raised through a certain height, or when a car moves a certain distance. In any of these examples given, you will see that there is change in position from one point to the other. In each of these examples, the amount of work done is measured by the product of force used and the distance moved in the direction of force. So if there is no distance, it means the distance is zero, and when you multiply the force by zero, you get zero work. That is why we say no work is done when there is no displacement, when there is no change in position of the object. Thus, work is equal to force times distance in the direction of force. So work is F times S, where F is the force and S is the distance. Now, if the force and the distance are not in the same direction, they are inclined at a certain angle theta, then the work is equal to F times S cos theta. Work is measured in joule, same as energy. And then they define 1 joule for us as the work done when a force of 1 Newton moves a distance of 1 meter. Okay, this illustration I like it so much. Let's say this is the object and the force acting on this object is in this direction. Okay, and then the body is moving in this direction. So we can clearly see that the direction of motion is different from the direction of force, and the direction of motion and the direction of force make angle theta a degree to each other. So we are not going to use F, rather this F has effective values in the horizontal, effective value in the vertical. In the vertical it is F cos theta sin theta, in the horizontal it is F cos theta. Since our body is moving along the horizontal, we are going to take F cos theta. So we take F cos theta, we multiply it by the distance, that will give us the work done. Okay, let's see an example. Oh, before that, they say larger units are, meaning the larger unit of energy and of course of work, are the kilojoule and the megajoule. 1 kilojoule is 10 raised to the power of 3 joules, meaning 1000 joule, and 1 megajoule is 10 raised to the power of 6 joule, meaning 1 million joule. Okay, here is an example. They say a body is pulled along a horizontal plane by a constant force of 10 Newton applied parallel to the plane. Okay, E says calculate the work done in moving the body a distance of 20 meters, and then B says what work has been done if the same force is used on the body for the same distance but applied in a direction making an angle 60 degrees to the horizontal as in figure 3.2. Okay, the first part of the problem is telling us that a force of 10 Newton is applied on a body and the body moves a distance of 20 meters in the direction of that force. So this is very easy. We use the formula work equals force times distance, and it will be 10 times 20, which is 200 Newton. So this is the solution. Work done is given by work is equal to force times distance. The force is 10 Newton, the distance is 2 meters. When we multiply these two, we get 200 joules. But the second part is telling us that the direction of the force and the displacement are different. They make angle 60 degrees to each other as seen here. This is the direction of the force, 10 Newton, and the body is moving in this direction and it moves through a distance of 20 meters. The direction of motion and the direction of force make angle 60 degrees to each other. Now we have to multiply Fs by cos theta. That's the only difference. So we say work done is equal to F cos 60 degrees times the distance 20. Okay, so F is 10 cos 60 degrees, and this will give us 100 joule from our calculator. Now, work done in a force field, such as gravitational field. The gravitational field is used here as a force field. So, the force, in this case, the force of the field is mg, which is the force of gravity, and the distance is the height. So, work done is mgh, where m is the mass of the body, g acceleration due to gravity, and h is the height. Now I want to make a general statement here. If an object is falling from a height, work is done by gravity and the work is mgh. If an object is lifted, okay, is lifted, then work is done against gravity, and the work done is still mgh. There is no difference at all. It's still the same thing. Okay. Okay, in the next video, we will see examples on this.